This video is going to go through how to eliminate the parameter when given a parametric equation and also examine some of the properties of that parametric equation. On page 45, we have a warm-up that includes a graph of a ship that is appearing on a Coast Guard's radar screen. Its path is shown on an XY coordinate grid, and what we need to do is graph the vertical and horizontal motion of the ship. So the first thing I'm going to do is I'm going to create a 3-column table. And my table is going to go T, X, Y. Okay. So now when time is 0, I see I'm at the point -3, 0. When time is 1, I'm at the point right here, 0, 2. When time is 2, I'm right here at 3, 2. When time is 3, I'm at -1, -2. And when time is 4, I'm at 4, -4. So now what I'm going to do for x of t is I'm going to graph the points like this. I'm going to graph tx. And obviously I'm going to need to pull this out a little bit. There we go. All right, so I've got 0, -3. I've got 1, 0. I've got 2, 3. I've got 3, -1. I've got 4, 4. So there's the horizontal motion. Now for the vertical motion, I'm just going to graph 0, 0, 1, 2, and so on. 0, 0, 1, 2, 2, 2, then 3, -2, and then 4, -4, which I'm kind of off my grid here, but that's okay. I'll put it right there. Excellent. Okay, so what we're going to do before we talk about eliminating the parameter is we are going to talk about some Algebra 1 skills. So, quick review from Algebra 1. Cannot get this the way I want it. There it goes. It's fine. We are going to talk about 2 methods of solving systems of equations. We are going to talk about the elimination and the substitution method. So everyone go ahead and write down. The goal of the elimination method is to create coefficients with opposite signs to add equations together to eliminate a variable. And what this means is I look at my coefficients, and here I have 2 and here I have 1. Those are not the same numbers. I have 2 and 1. Those are not both 2's and they're not both 1's. And they're also both positive. Here I have 3 and 1. Again, not the same coefficients. So for this problem, I'm going to work with my x's because I do like the 1x here. I could also use the y because it's 1y. This is a 2. This is a 1. For elimination, I want to create coefficients that are the same but opposite sign. So the first equation is 2x plus 3y equals 5. I'm going to multiply the second equation by -2. So now if I do that, I get -2x minus 2y, whoop, oh, leaky pen there, minus 2y equals -2. Now I'm going to add down. When I add down, the x's go away. I'm left with 1y equals 3. Now to find x, I'm going to take my y equals 3, and I'm going to substitute back into one of the original equations. I'm going to use the second one because it's just a little easier. So I have x plus y equals 1, which means that x equals -2. And I know that these two lines will intersect at the point -2, 3. That's the elimination method. Now, another method we can use to solve a system of equations is called the substitution method. And with substitution, our goal is to isolate a variable in one equation and then substitute it into the other. I'm going to take my bottom equation, again, because I have the 1x and 1y, and that's kind of nice. And I'm going to subtract y from both sides. And that leaves x equals -y plus 1. You could write y minus 1. I don't know, I did that. Now I'm going to pick up my -y plus 1, and I'm going to substitute it in for x. Go ahead and distribute that too. Combine my like terms. And again, I get y equals 3, which is not really a surprise because we just did this problem above. And now if I take my y equals 3 and I put it back here, I get x equals -y plus 1, and we get -2, which is the same solution we got from elimination. Now, it's important to know how to use substitution and elimination because we're going to now take our parametric equations and eliminate the parameter. And what that means, it's going to be our goal to either use substitution or elimination to get rid of the t. So let's take a look at page 47. Page 47, we are given a parametric equation, and we're going to work with it in parametric mode first, and then in letter C, we will use substitution or elimination to eliminate the parameter. We're given this first prompt. Think about it for a second. All y-intercepts on a graph occur when... Oop, that is not a straight line. So if you think about it, every point on the y-axis has an x value of 0. So using the parametric equation, at what t value does the y-intercept occur, we're actually going to use this top equation. And we're going to say x, well, we're not really going to say x, we're going to say 0 equals 2t plus 2, because it's when x equals 0. We're going to solve for t. -2 equals 2t. And we get t equals -1. So now that we have that t value, using the parametric equation, identify the y-intercept, we know that occurs at -1. And we get a y-intercept here of -5. Okay, now we are being asked to eliminate the parameter and write the rectangular representation. The first thing I'm going to do is I'm going to rewrite my parametric equation, and instead of x of t and y of t, I'm just going to write x and y, because it's a little easier to look at. And now I have to decide, do I want to use elimination or do I want to use substitution? And for this equation, you could do either. I'm going to use substitution because that's a little less common, because we have to really want to have a 1t. The fact that this is a 1 here makes it a good setup for substitution. So I'm going to isolate the t, because that's what I'm trying to eliminate. I'm going to add 4 to both sides, and I get y plus 4 equals t. Again, I want to eliminate the parameter. I want to get rid of the t. So now I'm going to take y plus 4, and I'm going to substitute it into that other equation. X equals 2 t plus 2. So now I have x equals 2y plus 8 plus 2. I have x equals 2y plus 10. Now I'm going to rearrange this equation so it's in slope y-intercept form, because looking ahead, it's asking me for the slope and the y-intercept, so obviously it would be helpful if this was in slope y-intercept form. So I have x equals 2y plus 10, and a reminder, slope-intercept form is y equals mx plus b I'm going to subtract the 10. I'm going to divide everything by 2. I know there's a 1 here, so I have 1/2 x minus 5 equals y. And lo and behold, there, it's the same -5. Oh. There's our y-intercept, -5. And there is our slope, 1/2. So for this problem, we used substitution to eliminate the parameter. Let's take a look at number 2. Now, number 2, you'll notice I have 3t and 4t, so this is not a good situation for substitution. If it's a 1t, substitution is going to be your friend. If not, we're going to have to use something else. All right, so using the parametric equation, at what t value does the y-intercept occur? As a reminder, that always happens when x is 0. So we're going to take our x equation and we're going to set it equal to 0. We're going to subtract 9. We're going to divide by 3. And we're going to get t equals -3. Okay, using the parametric equation, identify the y-intercept. So now we're going to be like, all right, well, what is y of -3? 4 times -3 plus 2, that's -12 plus 2. So our y-intercept is -10. Okay, eliminate the parameter. We need to get rid of the t. Again, I'm going to rewrite my equation a little simpler. I'm going to just say x equals 3t plus 9 and y equals 4t plus 2. Now, when we did elimination in Algebra 1, we could just pick what we wanted to eliminate. But here we are specifically eliminating the t, which means that we have to work with the 3 and the 4, even though the x and the y have 1s, but they're not the same variable, and that's not what we're trying to eliminate anyway. So we think about 3 and 4, and we think about their least common multiple. If I count by 3s or I count by 4s, what is the first number they have in common? So if I count by 3s, 3, 6, 9, nope, none of those are multiples of 4s. I actually do have to get to 3 times 4, which is 12. 12 is our least common multiple. I can make both coefficients a 12. I also want one of them to be positive and one of them to be negative. I can choose. I'm going to have the top be positive and the bottom be negative. So here we go. 4x equals 12t plus 36. -3y equals -12t minus 6. Now I'm going to add down. These are not like terms, so they just become friends over here. The t's will eliminate. 12t minus 12t is 0t, and then I get a 30. So we are in rectangular form, but since we do want the slope and the y-intercept, let's go ahead and put it in slope y-intercept form. I'm going to subtract the 4x. I get -3y equals -4x plus 30. I'm going to divide everything by -3. -4 divided by -3 gives us a positive 4/3 x. That's our slope. And then 30 divided by -3 is -10, which confirms our answer from above. This is how we eliminate the parameter to identify the slope and y-intercept from the rectangular form. Let's go ahead and start the homework so that everyone has a good start to it. All right, so on page 48, you'll see that the prompts are really similar to the prompts on page 47. So what I want to do with problems 3 and 4 is to come up with a plan to eliminate the parameters. How many are here? Oh, there's only 3. So I'm kind of happy. Number 5, there's that 1 there. So when I look at number 5, let's write in blue. When I look at number 5 on page 48, I'm thinking maybe I want to take this first equation and solve for t, because it's just 1t. And I can have x minus 1 equals t, and then I can substitute that here. And this is a good one for substitution. Now, to eliminate the parameter in number 3, there's a negative here. I mean, I could add t to both sides, and then I could subtract the x, and I could get t equals 4 minus x, and then I could substitute. That would work. I also could eliminate. Like, this is a negative 1. You know, I could maybe rewrite this a little neater. X equals negative t plus 4. Y equals negative 4t plus 2. I could multiply, if you really like elimination, I could multiply that top equation by negative 4 and then have coefficients of 4 and negative 4. So number 3 and number 5, I have choices. Number 3 and, number 4, there's really no choice here. I have 3 and we have 5. So I'm going to have to eliminate. I'm going to rewrite it just to make it a little simpler, because some people get messed up. They think it's like x times t. They forget that's a function of t. It's x is a function of t and y is a function of t. So here, it's, again, we're looking for common multiples. 3 and 5 don't really have a lot of common multiples. I'm just going to have to go 5 and 3, and they're both positive, so I will make the 3 negative. Go ahead and finish page 46. Anything you don't finish in class is